Hello everyone, today we're going to talk about functions. This is going to be your chapter 4 in Zybooks, and so let's begin with this. So going first into your definitions. Your definitions again, a function is basically something that maps different elements of one set to different elements of the other set. So it's represented by the alphabet F, and basically a function, if we have two sets x and y, then function is basically a subset of x and y, or x into y. So, and for every element where x belongs to, or for every element x which belongs to a big set x, there's exactly one and only one match for y which belongs to y. Now this denomination that you see here, or notation, where fx to y, this is basically a notation to express the fact that your function f starts at f and goes to y. So your x is called the domain and y is called a target. Now, since you have x and y as two different elements or two different sets, basically you can denote that as function of x is equal to y, since that's your target. Now you also have different types of arrow diagrams. The arrow diagrams define one set, basically the function of whichever set you're trying to define. You mark that on the left, and the elements of the target are denominated on the right. You have an arrow for each element x belonging to the set x going to y, which belongs to set y, and only if x and y both belong to f. Now you have x given as wxyz, a given as abcd, f given as wa, xa, yd, and zc. So what we're going to do is basically we're going to draw a diagram where everything in x resides on the left hand side, everything on a resides on the right hand side, and then we're going to draw arrows that maps this. Once we have that, you can basically define it as that whole thing where y belongs to y and everything in x belongs to x, and then x and y belong to f. So two functions f and g are equal if and only if they have the same domain and target, and this is true of every single element within that domain. You also have injective or one-to-one functions where domain of x1 belongs to x, domain of x2 belongs to x, if that is true, and you can see that right here. You have a surjective or onto if and only if the range of f is y. So everything, basically a domain of y belongs to y and x belongs to x, where f of x is equal to y. That's going to be your onto. And then bijective or a 1:1 correspondence exists if both of these conditions are true. So in a onto condition, your domain has to be greater than or equal to the target. In your 1:1, your domain has to be smaller than or equal to your target. And then in bijection, basically both of the conditions have to be true, so your domain becomes equal to your target. Now, Boolean functions is a little different, and actually I like this better because this works in zeros and ones. It's all logic, and it's literally if something is off, it's 0, if something is on, it's 1. So you have different types of rules now, and Boolean multiplication is denoted by the dot, which applies two elements from 0 and 1 and obeys standard rules of multiplication. So 0 into 0 is 0, 0.1 is 0, 1.00, 1.1 is 1. Logical, it's basically your logical symbol. Also, it's the same exact rule set here. Now you also have addition, which is denoted by the normal sum sign, and it applies to two different elements. Only thing is, with 1 plus 1, it doesn't become a 2, it actually remains a 1. With Boolean, everything always stays with zeros and ones. Just keep that in mind. And if you have two ones, then it's potentially going to be a 1. Now if you look at different other components, so you have a bar symbol, which basically reverses your element's value. That's equivalent to your negation. So variables that have 1 become 0 and 0 becomes 1, and you can have different type of expressions built by using your Boolean variables. So if you look at variable expression, so we're trying to look at xy plus 1 multiplied by z bar. You want to evaluate that with x equal to y equal to z equal to 1. That's what's been given. So x into y is 1 into 1, which is 1. Your 1 comes down as it is. Z bar is basically, z is supposed to be 1. So we negate it and we make it 0. So here what we have so far, remember multiplication comes first, sum comes later. So 1 multiplied by 2 is 1 multiplied by 0 is 0. So you have 1 plus 0, which is equal to 1. Now if you have the same x plus z, where you have 0 plus y bar, you have different values. Now make sure you remember parenthesis overrides everything else. So first figure out this part, which is 0 plus 1. Now that's going to be 1, but you have to negate it, so it becomes 0. Then you have that multiplication, which is again z is 1, so 1 multiplied by 0, which comes down to 0, and then you plug in the value of x, which is 0. Now different laws of Boolean algebra. So we're taking all the laws that existed and we're just applying Boolean to it. So keep this handy. This is going to be like your cheat sheet. Essentially that's the idea here. What else? Now you have different laws. All the laws that we just saw, we can use them to simplify a Boolean expression. So you have, let's say, xy plus bar x y plus zy. So if you use the distributive law, essentially you're taking the y out, which is x plus x bar multiplied by y plus zy. Now here this becomes, if you use the complement law, it becomes 1, and then you have y zy. Again use the identity law, take it out, you have your distributive law, and which brings us to y. So we understand that we can basically use Boolean laws to simplify Boolean expressions also. Now Boolean functions, this is more of an example. So Boolean function 0 of 1 raised to the power of n, going from 0 to 1, going to 0 or 1, is a Boolean function with different parameters. So f of x, y, z is equal to yz plus xy, where you have 0. So input and output table here shows that you have different combinations and you're just gonna plug them in for different values. So that's basically what your table is going to look like. So if you look at the first one, for example, 0, 0, 0, you plug that in because those are your values, your x, y, z, put it into this equation and you get 0. Now if you look at 0, 0, 1, same idea. 0, 1, 0, you have the same idea. Now this one changes because yz becomes 1, everything else becomes 0, so that becomes a 1. This is going to be different because x becomes 1, everything else is 0, and so on and so forth. That's basically everything to do with functions. Thank you.